8.8, the last section for this assignment. We're going to determine values in a linear relation. So we're going to use lots of different methods, whether it's graphing, table of values, equations. You've learned all about all of them, and we're just going to use them to solve some harder problems. So this question is, Ferd's a piano teacher. He earns $23 an hour, and he wants to earn $200. So let's find out how many hours he has to work to earn $200. So probably the first one, the hardest one, is the first one, and that's using the table of values. And how you do that is you say, okay, what if he works 1 hour? What if he works 2? How much money does he earn? Well, he earns $23 every hour. So 1 hour is 23, 2 is 46, 3 is 69, 4 is 92. So all I'm doing here is I'm adding 23 every time. Every extra hour is an extra 23. So if he wants to earn $200, well, we can't really get a precise answer from in here, but you can say he's got to work between 8 and 9 hours to earn his $200, right? Because at 8 hours it's 184, at 9 hours it's 207. So we don't know exactly how many hours, but we know it's between 8 and 9, and that's the best we can do. And really a graph is exactly the same. You see on this graph I put earnings on the y-axis because it's the dependent variable, and time, as always, is on the x-axis. So I went up by hours here. I chose a scale of 23s. I just followed this, right? So I figure that way they're always going to land on the grid. And you can see my little blue dots represent the different points. You can hardly see them underneath because I joined the lines. And I made, by the way, a straight line because he can work. I didn't do a dotted line, a straight line, because he can work, 4.5 hours. He can work 6.72 hours. He can work something in the middle. It doesn't have to be 1 or 2 or 3. And that's why it's a straight line, not a dotted line. So you draw the line. We want to know how many to earn the $200. So if this is 184 and this is 207, around here is going to be 200. Kind of follow it straight to my graph, follow it down, and you get somewhere between 8 and 9. And it is as well quite a inaccurate method of doing it, but you get the idea, right? We know it's between 8 and 9. That may be accurate enough, right? But if we want to use an equation, we can get the actual number. And to skip to the answer, he can earn it. We know it's 8.7. Okay, so how did I figure that out? Well, I'm going to make a big equation out of this. So I think your common sense might answer it way quicker than my equation would, right? If you just say, okay, he's got to earn $200, $23 an hour. Okay, you're not going to multiply because that would be some huge number of hours. You divide. And probably you would do that on your own. But we're going to follow the strategy that I've been doing all along by saying, okay, let's call it E the earnings, H is his hours worked. So his earnings is 23 times the hours he works, right? If he works 10 hours, he makes $230. So you think, what operation now? It's a multiply. So if I want to use this equation then, I know his earnings is 200, that's what he wants to earn. We're looking for how many hours he has to earn to do it. I'm going to analyze my formula right there by getting E by itself. So I divide both sides by 23 to do that. There's no add or subtract in this particular one, right? Because there's nothing to add or subtract, so I can skip that step. I just want to get H by itself by dividing by 23. So the amount of hours he has to work will be 200 by 23, or 8.7. And this really validates the work that we did here and here. This is the accurate number, 8.7. Well, we figured it was between 8 and 9, the two other methods. That's as accurate as we could get. Now we have a really nice number, 8.7 exactly. So if he can punch the clock at 8.7 hours, he'd be right on. All right, please turn off the video, try these questions, and we're going to start the video again at this section.